I'm a strong believer that as researchers, as analysts, as professors, we can do a much better job communicating our work, communicating our analysis, communicating our data, both to each other and to a wider audience. And too often what we do as researchers is we forget that who we're communicating with, our readers, our users, our audience, may not be the experts that we may be in that topic. And so what I'm going to talk about today is how to do a better job visualizing your data, with the goal being to improve the way you communicate your work so that more people can use it and more people can act upon it, so that your work can have a greater impact. This came to my attention really when I was working at the Congressional Budget Office. I worked at CBO for about 9 years. I spent most of my time working on Social Security issues at CBO. And as an analyst at CBO, I would write a lot of reports, like many of you do, right? We'd get some data, we'd analyze it, run some regressions, make a graph, make a table, drop it into a report, surround it by a bunch of text, edit it, edit it, edit it, revise it, edit it, edit it, edit it, revise it, and it'd go out to the world, and there would be silence, right? I wouldn't get any calls with questions, calls with clarifications. I wasn't invited to fancy DC congressional hearings. There weren't any fancy DC parties I was invited to. We were creating things like this. This is the first draft of a main figure from a report on Social Security reform. So we were looking at 30 different reforms using CBO's long-term Social Security microsimulation model. So 30 different reforms, and for each reform, we were going to show changes in benefits paid out from the system, taxes received to the system, the balance between the two, different trust fund measures for different years, for different metrics. We're planning to show to members of Congress a spreadsheet, right? That's what we were going to give them, a spreadsheet that they would have little time or inclination to wade through. Now, at the time I was working on this report, I attended Edward Tufte's one-day workshop. Now, I see some heads nodding. Many of you may have heard of Edward Tufte. In the larger world, Edward Tufte is sort of known as a modern data visualization expert or guru or godfather, right? Within the data visualization field, he is known as sort of a cranky old guy. He doesn't like lots of things. He hates PowerPoint. So I had to get through all of that, and I learned two things at Tufte's workshop. So the first thing I learned is that people are going to read your graphs. They're going to look at your visualizations. And in many years of graduate school and many years of professional service, no one ever asked me to think about my reader or think about my audience. I wasn't taught how to write well. I wasn't taught how to make good graphs. I wasn't taught how to give better presentations. That communication part of the job, communications part, was not part of the education. The second thing I learned at Tufte's workshop were spark lines. This is an example of spark lines. They're essentially just small line charts, so that you can take a complex chart or a dense data table and add some small charts at the end to break it up to make it easier to see the patterns. Now, spark lines were important to me at the time because I was working on this report. So I came back to the office and I tried to change what we were doing here. And so all I did was take a lot of those numbers out and replace them with small, we can call them spark area charts, okay? So that for the first option, you can see that the trust fund balance doesn't change over time, and the second one, it increases and it sort of flattens off, and the third one sort of continuously increases over the period. So that a moment's glance through this long figure of 30 options, you get the core of the idea of looking through this table. Now, from that moment on, we had great success with that, and I found a window in which we could improve the way I, as an individual researcher, as an individual analyst, and we, as an agency, can improve the way we communicated our work. So we started improving the graphics in our regular reports. We started creating new report types. We started making infographics. So this is an infographic on the long-term budget outlook from 2012. So this accompanies a 110-page report on the long-term budget outlook. And here what we're trying to do is highlight, bubble up the most important pieces of information for members of Congress who need those headlines, those statistics, those single facts, so that they can communicate to their constituents, to their colleagues, to their staffs. So one day in the summer of 2012, I'm in my office, probably critiquing one of Jim's graphs, and out in the hallway is a large television showing a House Budget Committee hearing. And I'm in my office, and suddenly I hear screams of, John, come outside, your infographic is on TV. And I go out, and sure enough, Congressman Chris Van Hollen from Maryland, who's now the senator, is holding up that infographic. And if you look really carefully, you can see he's scribbled all over the page. Now that's a win, right? That's a policymaker holding up an infographic in a congressional hearing. It is clearly not the only time CBO numbers have been used, as we can see just today. These numbers are used all the time, but it was the first time, I think, that I know of that a CBO infographic was used in a congressional hearing. And so from that time forward, I tried to figure out ways in which we can improve the way we as researchers, as analysts, as people working with data-rich content, can improve the way we communicate our work. So I'm going to touch on 3 things today that I think can help you on your way to creating more effective visualizations. But before I do, I want to take a quick pause, because what I'm not going to talk about today is presentations and how to give presentations. But I do want to make a quick pause. So here's from Twitter. We should have like gun control rules at all economics conferences. Like there's just too many bullets flying around at economic conferences. And 3D column charts too. So I just want to point out the 3 core principles that I have when it comes to presentations, and I'll move on to data visualization. The 3 principles that I have that I think can help everybody in this audience at this conference and in the next conference that you attend is to visualize as much content as you can. Take things out of those bullet points, make them graphs, use icons, use images, use things that are more likely for your audience to recognize and recall and hold on to when they leave the seminar room. Unify your content, both what you say and what you show, and how your slides look over the course of your presentation. As you unify your slides, it's easier for your audience to maintain their attention and to not be surprised every time you show them a different thing with a different color and a different layout. And then finally, focus your audience's attention where you want it. When you copy and paste Appendix Table 1 into your slides, no one can see that. Okay, so focus your audience's attention where you want it at all times. Okay, so that's just the side note, just the pause. But now I want to talk about 3 things about data visualization. I'm going to first talk about the purpose of data visualization. And when I talk about the purpose of data visualization, I'm going to think in spectrums or in axes. And the first spectrum is one that runs from analytics to presentation. Because you may make a visualization on your desk at Stata, in Excel, in SPSS, in SAS, whatever tool you're using, and that visualization is there for you to better understand your model, for you to better understand your data. But when you take that scatter plot and you put it on your website, you put it in a journal article, you put it in a working paper, that scatter plot is now for your audience. And you need to keep in mind who your audience is and how they're going to use that visualization. So things like annotation, color, font, layout, these are all elements and attributes that we need to be thinking about carefully so that our audience can get the information that we want them to have out of the visualization. Now, when I think in spectrums, or thinking about the purpose of visualization, I'm going to think in 2 perpendicular axes. The first axis is the form axis, and here visualizations run from static to interactive. Static visualizations are not active, they're not moving. Interactive visualizations are ones in which there's a 2-way exchange of information between the user and the interface. And then somewhere in the middle are animated visualizations. These might be films or videos where you can click, you might be able to interact, they may be combinations of static visualizations. The perpendicular axis is the function axis. And here visualizations run from explanatory to exploratory. Explanatory visualizations are ones in which I, as the creator, am telling you a story. I'm trying to get you to buy into my ideas, my hypothesis, my conclusions. Exploratory visualizations are ones in which I'm asking you as the reader or the user to go in and come away with your own ideas, own hypothesis, own conclusions, maybe take the data and do something with it on your own. And so if we put these 2 together, we end up with this schematic of the space of data visualization. And so what I'd like to do is walk through examples of each quadrant. So we start in the top left quadrant. These are static explanatory graphs. This is what we're used to making and seeing all the time. These are the line charts and the bar charts and the area charts. We've also seen lately the explosion of infographics. This is an infographic I made when I was at CBO. This paper, or this infographic, went along with a 90-page paper on federal means-tested programs and tax credits, so EITC, Medicaid, SNAP, child nutrition programs. And so you can see what we have here is a very short definition at the top, 2 sentences that describe what's going on in these programs over the period, a column chart that shows changes in spending over time, and on the right is a breakdown of 10 different programs into healthcare, cash assistance, and nutrition and education. Now, when I was asked to make this infographic for CBO, I called the authors and I said, I've been asked to make an infographic for your paper. What's the headline? What's the summary? And as 3 good economists are wont to do, they sent me a 2-page summary. And I said, no, you don't understand. I'm asked to make an infographic. What's the headline of your report? And as 3 good economists are wont to do, they sent me a 1.5-page summary. So we iterated like that for a while. And finally, one of the authors called me up and she said, the headline is, it's Medicaid stupid. I said, that's a great headline. We can't send that to Congress, but that's a great headline. But you can see here with that big blue bar at the top, it's Medicaid stupid. So that's where this infographic starts, and it's sort of modular in a sense. We have a second panel here that talks about what's driving these changes. Is it participation? Is it spending per participant? This is taking about 7 pages of text and boiling it down. You can think about it as just taking those topic sentences, because I'm trying to target a different kind of user, a different type of reader. In the third section, we have changes in spending, participation, and average spending per participant for each of those programs. I'm using here what's called a dot plot, so I'm not showing all of the data. Too often, we just show everybody all the data, and we say, good luck, try to figure it out. Here, I'm just showing 2 data values, 1991 and 2011, and in the left panel, you can see very clearly that it's Medicaid stupid. And in the final panel, we have what's CBO's value added, which are projected changes in 2012 and 2023, those 10 programs plus the exchange subsidies. And you can see on the far left side, well, maybe not after today, but in the far left side, we have the change in Medicaid, so it's changes in Medicaid stupid. Okay, so those are static explanatory graphs. What about static exploratory graphs? So again, here we're asking our user or our reader to dive into the visualization and come away with their own ideas, their own conclusions. This is an infographic from designer Christina Schuchs that looks at the relationship between a movie's profitability and its critical reviews. So for each one of these little glyphs, each of these little icons, we have 2 vertical lines. The left vertical line shows the movie's Rotten Tomatoes score, and the right vertical line shows the gap between the movie's worldwide gross revenues and its budget. So the gap, the height there is showing the budget, or the profitability. And so if you go through this visualization, what you notice is she's not telling you a single story. She's not telling you a single conclusion. She's not telling you that dramas have become more highly rated over time or that comedies are more profitable than thrillers. You as the reader have to go into this visualization and explore the data on your own and come away with your own ideas and conclusions. Now we go into the bottom half of this schematic, the interactive side. Now, a lot of people get excited about the bottom half of the schematic because that's where the clicking happens. When I was at CBO, we didn't live in the bottom half because we didn't believe Nancy Pelosi and John Boehner were going to sit down and click around with the thing. It just wasn't going to happen. But for those of you who are interested in creating these interactive visualizations, there has traditionally been a 3-step mantra. The 3-step mantra has been overview first, zoom in filter, and details on demand. You give the user the overview, you let them filter in, and you give them the details on demand. That has changed slightly because of mobile technology where really no one wants to click on anything. But I'm going to show you some examples from this overview, zoom and filter, and details on demand. The first example is from the New York Times. This is from their visualization of President Obama's 2013 budget proposal. What you have here is what's called the circle packing diagram. Each circle represents a part of the president's budget packed within a larger circle. And so you get that overview of the budget by the circles and the colors. You can then zoom in and filter by selecting these tabs. Do you want to see it by type of spending? Do you want to see it by change? Do you want to see it by department total? And then you can zoom in and filter by selecting each of those circles so you can get more information in the tooltip above. This is another example from the OECD, their Better Life Index. So OECD, as you know, has lots of data. They've collected that data to create what they call a Better Life Index. So things like education, jobs, housing, incomes. And so each one of those elements in the index becomes a petal on each of these flower glyphs. So you can go in, you get the overview of the entire space because of those flowers. You can zoom in and filter both by changing the relative weights of each of the inputs into the filter, or you can go in and select the countries, select the indexes to get more and more information. So that you get the overview, you get to then go in, zoom and filter, and then once you're in each of the countries or in each of the metrics, you can get more details on demand by playing with these little bar charts, by downloading the PDF reports, or even going into their data tool. The final quadrant are explanatory interactive graphics. The simplest way to think about this are just take your standard charts and add interactivity on top of it. So these are simple line charts from the World Bank. You can click, you can highlight, but these lines are still going down and these lines are still going up. But we can still tell stories or give explanations through interactivity. This is the New York Times project, The Paths to the White House. This shows all paths by which Donald Trump or Hillary Clinton could have won the presidential election. So you get to go in and select which states you think each candidate's going to win. You can easily imagine this written out in text. But by interacting with it, you get to see the relative paths and the relative combinations. Okay, so that's this space. Now, as I mentioned, somewhere in the middle are animated visualizations. It doesn't mean that they're the best. It just means that they have combinations of these 4 quadrants. This is Aaron Coblin's Flight Paths project. It shows all flight paths in US airspace over a 24-hour period. So you can see, as we go from daytime to nighttime, the country largely grows dark. You see people take their red-eye flights from the West Coast, cross the country to the East Coast. And as we near daybreak, you see flights come over the Atlantic from Europe, and then the East Coast wakes up. And as we go across the country over the course of the day, the airs wake up, and more flights go across the country. As we near the end of the day, you see folks on the West Coast in San Francisco and Los Angeles make their journey southwest to Hawaii. So this visualization has aspects of these 4 quadrants. It allows you to explore data about US airspace by zooming in, by zooming out, by rewinding and fast forwarding the video. It works as a static visualization. It works as an explanatory visualization where you get different feelings, different stories out of this visualization than you might get from a table or a bar chart or a pie chart. Okay, so that's the first thing I want to talk about was the purpose of data visualization. The second theme I want to talk about were strategies to create better visualizations. And here's where I'm going to try to get as practical as I can. And it's important to be visual, as I mentioned at the front, because as John Medina writes in his book, Brain Rules, the more visual an input becomes, the more likely it is to be recognized and recalled. So as you're making your slides tonight for tomorrow's lecture, which I know people are doing, try to get the numbers out of the tables. Make visualizations, make graphs. A simple bar chart is much more likely to be recognized and recalled than that regression table. Now, how do we process visual information? We use a process called preattentive processing. And the formal definition for preattentive processing is cognitive operations that can be performed prior to focusing attention on any particular region of an image. In other words, it's the stuff you notice right away. So when I show you this image, now the guy in the yellow and the black, for those who don't know, his name is Odlaw. He's the bad guy in the Waldo books. It's Waldo spelled backwards. I recently found out that most people don't know who Odlaw is. So the guy in the yellow and black, his name is Odlaw. Now when you look at this image, you can very quickly find Waldo in this picture. And why is that? Well, Waldo's wearing different colored clothes. He's got a red and white shirt. He's got blue pants. He's holding a cane. His head is held at a slightly different angle. And those attributes are things that we use to pay attention to parts of this image. And we could take these preattentive attributes and apply them to our visualizations. So things like shape, enclosure, the width of a line, color, the saturation of the line, these are all things that we can add or include in our visualizations to draw attention where we want it. So we focus our reader or our audience's attention where we want it at all time. So let's test this just very quickly. Here's basically what we do to each other every day. Here's a spreadsheet. Tell me the story. Okay, so count for me the number of 3s. Now, don't really do it. But what you're all doing right now is going number by number to find the 3s, and then your hand that stands below your chair, you're counting them on your fingers. But what if I use some of those preattentive attributes? What if I colored those 3s red? What if I highlighted them to use enclosure? These are all preattentive attributes that make it easier for your reader, for the audience, to see the story, to see the explanation, to see the conclusion you want them to find. What about a line chart? The preattentive attribute are the points of that line and the angle of the line that connects them. If I added a box around the forecast area, it draws your attention to the right side of the image. That's a preattentive attribute. What about a scatter plot? The preattentive attribute of a scatter plot are just the points on the page or the screen. And your attention may be drawn a little bit to that point out to the right, which might be an outlier. But we can highlight that even more by adding color. I could add color to the rest of the points to draw your attention around the graph where I want it. And finally, we could test with a bar chart. The preattentive attribute of a bar chart is the length of the bars. But instead of just saying, here's a bar chart, good luck, we could add preattentive attributes. I could highlight the first 2 bars, draw your attention there. I might even add color and desaturate the next 2 bars and de-emphasize those and add some text to this graph to help tell that story. So the first practical thing I want to leave you with is to start with gray. When you make your visualizations, start with gray. Here's your standard Excel chart. I can insert and publish to wherever I want. Looks like it was made in Excel. No problem, you could read this. You don't get anything really out of it. But if I made all those lines gray, I can't give this to you because you won't be able to figure anything out. And now as I start with gray, I as a creator have to be strategic and purposeful with what I do with this graph. So now I could add red to this line to draw your attention to that line. And maybe I'll color in the other lines and I'll clean this graph up. And we see this all the time in practice from some of the top places that do data visualization. This is from NPR. This is graduation rates for all states in the US plus the nation. And you can see how the graduation rate for Alabama is thicker and colored red, and for the nation it's thicker and colored orange. Those two pre-attentive attributes draw your attention to those lines on the graph while still giving you the relative picture of the rest of the country. Back in the nomination process last summer, the New York Times did this story on the nomination process. They started with this big gray box. The US is home to 324 million people. Each box is a million people. And then they walked through this visualization step by step, highlighting each part of this gray box, purposefully adding color, purposefully adding annotation so that they walk you through. Okay, so I'm going to talk about strategies. I'm going to talk about 5 different things. And each one I'm going to try to move from ineffective visualizations to effective visualizations. So the first strategy I want to talk about is moving from cluttered to uncluttered. So this is a graph from JPAM. Now, when you look at this graph, what's the first line you see? Well, first off, this is a graph that's plotting the coefficient results from 4 models that are looking at the relationship between the unemployment rate and food stamp participation. Now, when you look at this graph, where does your eye go first? The 0 line. I heard someone say the 0 line. The 0 line. Why the 0 line? Because it's dark and it's thick. Because that's a pre-attentive attribute. And the 0 line is not the most important line on this graph. Right? The coefficient line is the most important line on this graph. So we're not emphasizing the data. We have lots of tick marks. They're probably unnecessary. There's 28 different percentage signs. There's 4 y-axis labels. I have no idea what WE stands for. And for the love of God, JPAM, at least spell them out below the graph. No. You have to go 15 pages earlier in the article. If you're anything like me, you read the abstract, you flip through the tables and the graphs, you come to this graph and you have no idea what they're talking about. And then there are 2 data points that are just not on the graph because it's inconvenient to go to plus or minus 20%. So here's one way that I might remake this graph. I've lightened all of the grid lines. I've made that 0-axis grid line slightly darker than the rest because it acts as a base for the series that drop below 0. I've eliminated 2 sets of y-axis labels and 2 sets of x-axis labels because the charts are aligned horizontally and vertically. I've spelled out each of those abbreviations, so now you know that WE stands for Welfare Cash Assistance. Okay? And I've moved the word caseloads, which appeared 4 times in the original, I moved that into the top, into the title. And the most important change I made was I made the darkest, thickest line the coefficient line. Now, we could quibble about this. You might want to have the labels back on. You might want to have dashed lines instead of solid lines. You might want to add color. You might want to fill it in. Those are all things that we could do. But this version, I think, does a better job of showing the data and reducing all that clutter and all that stuff around it so that it's easier to see the data. I call this one a clutter plot. This is from Journal of Economic Perspectives. Now, a couple things that I think we can all appreciate in this room. First off, it's very clear that this was made in Stata. It's got that blue Arial font. Everything's capitalized, so it yells at you. Secondly, we can all appreciate that the journal thought that this graph could use some improvement, and so they added the word China up in the top left with an arrow that points to the point, also labeled China with CHN. Now, in the article, the author talks about China relative to 4 other countries: Thailand, Malaysia, Costa Rica, and the Philippines. Now, if you know those 3-letter codes for those 4 countries, some of you do, I'm sure, you can go try to find them here. Hard to do. But what if we think about the audience and think about our reader? All I've done here is gotten rid of the labels. I've lightened a lot of those points. I've decluttered this graph. I've highlighted those 4 points in green. I've added the labels directly, and I made the China point a little darker with the label. Now, someone might say, well, yeah, but someone wants to know where Denmark is in this space. Okay, first off, no one really wants to know where Denmark is in this space. Secondly, even if they do, we are far beyond the time and place where there's only one way to get information to our readers. The author here has his own website. He has a department website. This was an NBER working paper, and the journal has a website. That's at least 4 places where an Excel file or a CSV file or a TSV file or Stata code could live, where the person who wants to know where Denmark sits can go look at it. But the author is telling the story about these 5 countries. Okay, so I've gone from cluttered to uncluttered. Let's go from separated to integrated. The simplest, what I'm talking about here, what I'm thinking about here, is integrating the text and the graphs together. And so the simplest way to think about that is getting the legends that sit off disconnected from your content and moving them onto your graph itself, directly labeling the graph. So that in this graph from Social Security Advisory Board, we have a legend that takes up a lot of space on the right side. And if you look carefully, the order of the legend doesn't match the order of the lines. So you have to go back and forth sort of twice. Okay, so here's one potential very simple remake. I got rid of a lot of those data markers. I got rid of a bunch of the grid lines. I lightened them up. And I added the text right onto the graph. And I had the color of the text match the color of the line. Very simple to do. This is not magic. Okay, one more from SSA. SSA and USDA tend to show up in my slides a lot. USDA, we have a simple column chart here. Now each column has 5 things that are telling you the same piece of information. There's a left outline, a right outline, a top outline, a fill, and a number. We have these weird sort of spaces between the columns, should be pushed together, and a legend that sits up there disconnected from the graph itself. So here's one potential simple remake. I've lightened the grid lines. I got rid of the outlines around the bars. I pushed those bars together. And I added that legend right onto the graph, directly labeling the graph. Now, a lot of people ask me about tools. What tools do I use? You know, what coding languages am I using? This was all done in Excel, and this was not done with any text boxes or drawing lines. Everything here is done with using data. So for those of you who are making your graphs in Excel, this is how it's done. It's a column chart with 6 scatter plots put on top of it. And each scatter plot has error bars wrapped around them. And each of those points are linked to the data, so that when I update this graph and all the columns go up by $5,000, all the lines and all the labels move along simultaneously. That way, I can update this graph more easily, and I can move it from Excel to PowerPoint with one copy and paste instead of having 7 different objects. So that's the first integrating text and graphics. Get those legends, get rid of the legend, and integrate the text onto the graph itself. The second thing, the more complicated thing, the thing that we as researchers, as people creating data-rich content, don't do enough is annotate our graphs. Where we annotate the graphs to tell our user what they're supposed to get out of the graph. Here's a very simple line chart of the rise and fall of BlackBerry. By the way, just so you know, don't make fun of BlackBerry when you talk to the Department of Justice. They don't take it very kindly because lawyers still use BlackBerries. But if you look at this graph, it's just a line chart, and the author has added 5 different little sentences to guide you along the graph so that you're not guessing what's going on. Here's a simple graph from an NBER working paper. We can all read this graph. We all look at this graph. We know immediately what's going on because the working paper is written and designed for us. But what the NBER also does, which I think is great, is has a digest. And the digest is blasted out to a wider audience. And so notice what they did with this version of the graph. They got rid of the confidence interval bands. They've shaded in the right side of this graph, a preattentive attribute, and they added 2 very simple pieces of annotation. Less likely to be below 200% of the poverty line, more likely to be below 200% of the poverty line. Very simple annotations that everyone in this room can do. This is a scatter plot from the New York Times. We have men's weekly earnings on the x-axis, women's weekly earnings on the y-axis. Everyone in this room can read a scatter plot. But not so necessarily for the average New York Times reader. And so notice what the Times has done. They've added 4 diagonal lines. The 45-degree line, thick and bold and black, is labeled equal wages. So when I come to this graph, I know, oh, if this industry lies along this line, men and women earn the same in that industry. But what happens when I get off the line? Well, if I end up in this spot, notice that we have 3 other diagonal lines. Women earn 10% less than men, 20% less than men, 30% less than men. So that the average New York Times reader, or any reader for that matter, can go in and get a sense of the magnitude of each of those points. So final example, this is probably my favorite, of an extraordinary use of very simple annotation. This is from the LA Times. It's a bubble chart. It shows the relationship between the change in violent crime rates shown on the x-axis and the change in property crime rates along the y-axis. Everyone in this room is best fitting the line right now. I can hear the mental wheels turning. But the average LA Times reader is not best fitting a line to this space. they may not have even seen a bubble chart before. And so notice what the LA Times did. In the top right quadrant is a big red box with a big red word that says worse. And in the bottom left box is a big blue box with a big blue word that says better. So even if I don't know how to read this chart, I know that that stuff up there is bad and that stuff down here is good. And then I have a small boldface headline and a sentence below each, so that the annotation on this graph delivers to me both how to read the graph and also the content that I should walk away with. Now I've gone from separated to integrated. Let me go the other way. Integrated to separated. And what I'm thinking about here is spaghetti graphs. Spaghetti graphs where we put too much stuff on the chart. We just put it all on there and we say, hey, good luck to you. And one way to remedy that is something called small multiples. Or instead of putting everything on the chart, you break it up and make smaller versions. So you can see we have some spark lines there on the top left. But also, this can be applied to any graph type. Maps, lines, scatter plots, bar charts. Here's another example from Social Security. Now, any guesses as to what tool was used to make this graph? Right, okay, so first off, I'll talk a little bit more about this in a moment. Don't do this, okay? Don't use Excel's defaults, or Stata's defaults, or SAS's defaults, because it looks like you just did what this person did, which was insert, line chart, and publish, and that's it. So now with 4 lines, I find this chart hard to read. It's just, there's something about the pattern that makes it hard to read. Well, I can break up this very simple line chart into small multiples. Here I've created 4 versions of the same chart, and I've just highlighted a different line in each of the 4 versions so that you can more clearly see the patterns in each of the charts. Okay, so I've talked about cluttered and uncluttered, separated and integrated. Let me talk about circles and bars, because one of the big debates in the data visualization field is whether we should use pie charts or not. You have 2 sides of the argument. You have one side that said pie charts are great because I know the sum of the slices sums to 100%. It also reminds me of pie and pizza and round foods, and that's delicious. The other side of the argument says we're not very good at discerning the quantities formed by the angles of the slices in the pie chart. Okay, so let's do a couple of quick experiments. So here's a pie chart built in Excel. What are your guesses as to the share of the total represented by company C, the red slice at the bottom? Just yell them out. We're all friends. Okay. Okay, maybe one at a time. 30? 25? 20? 20? Okay. And some others. Okay, so somewhere between 20 and 30, that'd be fair. What if I rotate the graph very slightly? It's very clearly 25%. And why is that? Well, it's because we now see the right angle, which is familiar. Those 90-degree increments are very familiar to our eyes and our brains. And just reorienting the data changed how we discern those quantities. Now the first camp in this argument, this is the graph that they like. They like the part-to-whole relationship. They like being able to see the relationship between one slice and the whole. But when we put them together, it gets harder and harder to make these estimations. So let's do another experiment. Shares of the total represented by the purple slice, company A in the top left, and we'll do it this way. So I'm going to count up from the range that I've heard. And just raise your hand when you hear the number that corresponds to your belief of that purple slice. So we'll start at 5%. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 35. One person guessed 35 once. I don't know why. Okay, so I really should do a study on this because it is the exact same pattern every time. There's a spike at 8. A spike around 10, a smaller spike at 11, another spike at 13. Okay, so let me show you what happens when I take these data and plot it in a column chart. Now, 2 things have just happened. The first thing that happened is all the people that guessed 10% are going like this. They're cheering themselves on right now. You don't get a prize for guessing 10%. The second thing that's happening is the pie chart defenders are all up in arms because I've added grid lines and tick marks. And I do that because that's how we see these charts in the wild. And that, we don't add tick marks to our pie charts. This is how we see column charts and bar charts. And we are just better able to discern quantities from the lengths of the bars or heights of the columns than we are the slices of the pie chart. And here's where the pie chart defenders come back and say, yes, but I don't know this is part to whole. And that's a legitimate concern. And there's not a lot of solutions to that except to maybe integrate that into the title. Say it's a % of the total, a share of the aggregate. Now, I am not a pie chart hater fundamentalist. I don't make pie charts, but I'm not a fundamentalist about it. I'll say this. If I were to make pie charts, I would restrict myself to 3 or 4 slices. Why? Because 5 or more is just hard to figure out the quantities. 2 slices, I'm really just showing you one number, right? And I'm not sure I need a graph for that. So 3 or 4. But if I still haven't convinced you, there are really only 2 rules for pie charts. There's a hard rule and a soft rule. The hard rule is the pie charts have to sum to 100%. You think we would all know that, but when SSA leaves out that little bitty slice there, it's not rounding. Okay, that's the hard rule. The soft rule is, you can't write this, you can't make this stuff up. The soft rule is you should try to orient your data so that you go clockwise, largest to smallest. I say it's a soft rule because you notice here in this example, in the pie chart on the right, the other category is 4%, ends up in the last position. Not so in the 1962 pie chart on the left. And yet I would say that that's okay for 2 reasons. 1, you want the slices to be in the same position. And 2, the other sort of ends up in the last category. That makes sense. What are the alternatives to this? Here's a stacked bar chart. You still get that part to whole relationship. I've added lines here to draw your attention to the series that change. Or I could use what's called the slope chart. Here I have 1962 on a left vertical axis and 2009 on a right vertical axis. I've colored the 2 series that are declining. I've colored them in red, the 4 categories that are increasing in blue. But here I don't get that part to whole relationship. This is more about the change over time. Okay, so some debate about bar charts and circles. Less of a debate about using 3D. Okay, and I'm going to talk about, not this case, this is a fascinating piece from the New York Times about the yield curve. They actually had 3 variables, 3 dimensions were appropriate. This is very rarely done well. I'm talking about 3D when we do stuff like this. Don't need to do this, okay? Why? Okay, well let me try to explain. So if I have a pie chart with 3 slices, each slice of the pie takes up 1/3 of the page of the screen. If I rotate that pie, make it 3D, that front slice now takes up a much higher proportion of the page of the screen. So it's not a knock on pie charts, it's a knock on actually distorting the data. I can do the same thing in a column chart. In the 2D representation at the top left, that first column is very clearly 40%. When I rotate the chart, that first column no longer looks like it's 40%. Now why is that? Because what the software tool does is try to give you a perspective rendering. So if you were to bend all the way down and imagine a plane running along the top of that column, it intersects that 40% grid line. But that's not what it looks like when we look at it. Same thing for this. This is from the USDA. First thing you have to do with this chart is you have to ignore the y-axis. The y-axis label is millions/billions. It's a choose your own adventure type situation. If you notice the certification bar on the left, the certification bar is labeled 1833. I don't know if that's millions or trillions or what, but no part of that column actually touches the 1800 grid line. And that's because a plane runs along the top of that column and intersects that background at 1833. But that's not what it looks like when we view the graph. Finally, we've seen these a lot. This is from Journal of Women, Politics and Policy. I call these cityscape diagrams. Any guesses as to the share of never married white non-Hispanics? It's back there somewhere. So good luck. Okay, last strategy. Going from default to new. So any guesses as to what color palette, what tool uses this color palette? Excel, right? I have nothing against these particular shades of red, green, and blue. You might love these shades of red, green, and blue. Your entire house may be decorated in these shades of red, green, and blue. The problem is that everybody uses these shades of red, green, and blue, and so your graph looks like everybody else's graph. So avoid the default colors. It's very simple to input a new color palette. Excel has, in its page layout tab, 50 other color palettes. Many of them are just as bad or worse than the default palette, but at least they look different. You can load up a different scheme in Stata and do something different than using the defaults. This sort of graph says to me as a reader that all the content producer did was hit insert, stacked column chart, publish to the web, and they went to lunch. The other thing about color is to avoid the rainbow color palette. There's really a couple of reasons for the rainbow color palette. The first I want to demonstrate by showing you this map. This is a map of the evapotranspiration, amount of water going back into the atmosphere. When you look at this map, there's that really stark line right down the middle of the country. When I saw this map, I thought, well, they ticked up for a little bit and then they just said all else, and so you get this weird artifact. But it's actually not the case. The legend all ticks up by 0.09. It's not a problem with the legend, it's a problem with the rainbow color palette. If you look at that rainbow color palette, the green spectrum is much wider than the yellow spectrum or the light blue spectrum. So if I go from a unit change from, say, 2 to 3, and I'm in the greens, you might not see a perceptual change in the greens. If I did a similar unit change from 9 to 10, but was in the blue part of the color palette, you would see a change from a light blue to a dark blue. So we don't want to use the rainbow color palette. Secondly, when I make a map of, say, poverty rates, and I say that the high poverty rate states are in dark blue or in dark gray, and the low poverty rate states are in light blue or in light gray, that makes sense. That single color ramp makes sense. It's hard for me to say that purple means more than orange. That's not really a logical statement. A similar thing with fonts. To avoid the default fonts, I could spot from my hotel room who's using the Calibri font in their slides. Look, these well, maybe not Comic Sans, but the rest of these fonts may be perfectly fine. It's just that everybody uses them. There are lots of other great fonts default on everyone's machine. Century Gothic, Lucida Grand, Verdana. These fonts are standard. You can share them with one another. It's just that nobody uses them, but they're all sitting right there. And if you want to take it a step further, you can go out and get lots of great fonts for free. At the Urban Institute, we use the Lato font, but you can see some of these other fonts as well. These are all free that you can download and use. Okay, so I've talked about the purpose of data visualization. I've talked about strategies to create more effective visualizations. The last thing I want to talk about with you today is how to pick a graph for your data, because this is one of the primary questions. There's no one-to-one correspondence between data type and graph type. If there were, this would be easy. I have time series data, and I plug something in. So to try to help people make this decision, I teamed up with a friend of mine, a designer friend of mine, to create a project that we call the Graphic Continuum. This is the current version of the Graphic Continuum. This is the picture of the poster. It has over 90 different graph types, split into 6 different categories: distribution, time, comparing categories, geospatial, part to whole, and relationships. And you can see some of these linking lines and little boxes that sit on the poster. And what those lines do are show some of the overlaps. So that I could use a column chart, for example, to show changes over time. I can also use a column chart to compare categories. So again, there is no one-to-one correspondence between data type and graph type. So we made this poster, people are very excited, and then I started getting emails from people who said, I work in a cubicle, I don't have room for a poster, can you make me something else? So we made this little sheet, again, over 90 different graph types. Then we made flashcards, because I'm basically a glutton for punishment. So the idea here is there is no answer, but that what we're trying to do is create a library for people, so that instead of saying, whatever's in my Excel drop-down menu, that's all I can create, though you should never create the 3D cones, there's lots of other options out there that you can use to create data, not because they're inherently better, but because sometimes when we see data in different ways, when we present data in different ways, it allows us to see insights, make discoveries, and make conclusions in different ways. So what I want to do to close up today is to tell you about this Graphic Continuum project. Now, the Graphic Continuum project itself is inherently nonlinear. It's inherently complex, because you can use different graph types for different data types. And so what I'm going to do to tell you about this Graphic Continuum project is I'm going to borrow one of my kids' books. Now, if you have kids, you may be familiar with these books. There's If You Give a Moose a Muffin, If You Give a Pig a Party, If You Give a Mouse a Cookie. There's a whole bunch of them. If you don't have kids, you should become familiar with these books, because they're all fantastic. They all use what's known as a circular storytelling device. So that in the case of this book, the kid gives a moose a muffin, who eats another muffin and another muffin and another muffin until there are no more muffins. So they're going to go to the store to get more muffin mix to make more muffins. So first they have to get their jackets on. They get their jackets on. There's a hole in the jacket. Then they have to get needle and thread to fix it. They get the needle and thread. Then they start making sock puppets. And it just circles all the way back until the moose remembers that he wants to get more muffins. So I'm going to tell you the story of this Graphic Continuum, but I'm not going to use my kid's book. I'm going to use my own version of this book. So let's begin. If you give a nerd a number, he might want a table to go with it. And he could add another number and another number, but let's first focus on that first number. And he could take that number and he can plot it in an XY space. And he can add another number, and even more numbers. And this might remind him of other shapes he could use to plot these data. It might remind him of a stacked area chart or a normalized area chart, or even other graph types might remind him of a paired column chart or a stacked column chart. This might remind him that he could rotate the space 90 degrees to create a paired bar chart or a stacked bar chart. And if you go back to those lines, he could add more and more data. And this might remind him that he could break this chart up to create spark lines or small multiples. And with the spark lines, it might remind him that he could focus just on the endpoints of this graph, and that may lead him to think about a slope chart. Or he could rotate it 90 degrees to create a dot plot. And all this uncertainty about what graphs we use for what data we have may lead him to think about uncertainty, may lead him to think about a fan chart, or a box and whisker plot, or a violin chart. And if you were to add a secondary vertical axis to that line chart, it may lead him to think about correlations, which may lead him to think about a scatter plot, to which he could add a third variable to create a bubble chart, or the unfortunate 3D bubble chart. He could combine the lines with the correlations to create a parallel coordinates plot, or a radar chart, or you can combine the correlations with the time to create a connected scatter plot in which correlations are plotted over time. Then this may lead him to think about connections, may lead him to think about a network diagram, or a force-directed layout, or a hive chart. And the curves in the hive chart may lead him to think about a chord diagram, and the arcs in the chord diagram may lead him to think about an arc chart. And he can combine the time from earlier in the line chart with the arc chart to create a sequential arc chart, in which time is plotted from point A to point B to point C, and point A to point C. And this may lead him to think about time, which may lead him to think about a flow diagram, or a tree diagram, or very simply, a timeline, to which again he could rotate 90 degrees to create a Gantt chart, or very simply a calendar. And he could take the circles from earlier and the calendar, combine them together to create a nightingale. But a nightingale is really just a circle that's been exploded out in all different directions, so he could rein that in, and that may lead him to think about a pie chart, to which unfortunately he could rotate to create a 3D pie chart. He could blow it up. He could punch a hole in the middle of it. He could cut it in half, or he could blow it up again. But all that is just a variation on a circle. And this may lead him to think about other shapes he could use, may lead him to think about squares to create a tree map, to which he could blow up again to create a square cloud, or he could stack on top of one another to create a unit chart. And the squares in the unit chart may lead him to think about other shapes he could use, may lead him to think about people or an isotype chart. And the people in the isotype chart may lead him to think about high-frequency data, which may lead him to think about a heat map, or a contour map, or the truly unfortunate 3D contour map. And this very simply may lead him to think about maps, to which he could add circles, or squares, or lines. And the connections formed by the lines on the map may lead him to think about a specific point on this map where he's talking about how to think carefully about creating visualizations that help your audience find insights, make discoveries, and use your results for impact. And he could take that point off that map and he can plot it in an XY space. And so if you were to give a nerd a graph, he might want a number to go with it. So that's this graphic continuum project. A library of graph types to get you thinking about all the different ways that you can visualize your data. That there's more to the world than line charts, pie charts, bar charts, and area charts. The important thing to keep in mind is that the purpose of your visualization meets the needs of your audience. That you think about who your user is, who your reader is, who your audience is. That your work tries to help your audience do their job better so that they can make insights, they can make discoveries, they can put your work into practice and have an impact. What's important is that we think carefully about all the different arrays of visualization types that are available to us, not because new visualization types or different visualization types are inherently better, but because sometimes when we show data in different ways, it allows us to see things in different ways, it allows our audience to see things in different ways. I'm confident that anyone in this room can do this. I'm confident that anyone in this room can declutter their graphs, that they can add annotation to their graphs, and they can think about their audience first when they are creating their visualizations, when they're delivering their content. I certainly learned how to do this, and I believe you can as well. Thank you very much.